The same standard from last week. Standard 2, Standard 3 from statistics. We're still working with mean, median, and mode. We're also working with the standard deviation. Today we're going to revisit that, and we're also looking at attend to precision. Since we're working with computation and decimals, we need to be precise. So our objective for today, I can represent data on dot plots and compute the standard deviation. Let's read together. 1, 2, 3. I can represent data on dot plots and compute standard deviation. Let's read it again. 1, 2, 3. I can represent data on dot plots and compute standard deviation. So I just want to revisit standard deviation because I sense a little bit of disturbance in the force. So copy that the objective at the bottom left of your Cornell note. Do that right now. All right. So dot plots. This is a concept from last year. Some of you saw it in 7th grade, but I'm going to revisit it today just to make sure we got this. So what are dot plots? Dot plots is a data representation that uses a number line. What does it say? A number line. Does it say number lines? No. A number line, using X's, dots, or other symbols to show frequency. Copy this down. Example. They give us a number line, and on the number line they have it scaled by 5s, I believe. Oh, I remember this. Starting at 20, yeah. And then we got 20 dash 30 dash 40 dash 50 dash 60 dash 70, and that number line is titled salary in thousands of dollars. Copy that, please. So according to the definition, it says using a number line. Is this a number line? Yes. Do they use X, dots, or symbols to show the frequency? Yes. So that's a dot plot. Let me show you what is not a dot plot. Let me move this out of the way. It looks kind of like a dot plot, and they throw you that curve because there's dots, but this is not a dot plot. Okay, well, according to the definition, look up, please. According to the definition, we said a number line. We said, yes, it's right here. They use X's to show the frequency. So think about it. Why is this not a dot plot? Don't say it out loud. Why is this not a dot plot? As you're copying it down, think about it, and then I'm going to have you share with your neighbor. So yeah, that is correct. This is more like a coordinate plane because it's got two different axes. It's got the X and the Y. This one only has one number line. Therefore, the most important to remember about dot plots, that they have only one number line, shows frequency, and uses X, dots, or symbols. Copy that, please. Okay. Steps. For steps, we're looking at 4 steps for today. We got identify the mean, median, mode, and range. And we know how to do that, right? Yes. Step 2, identify the standard deviation. Like I said, we're going to revisit that and practice some more. And look at the symbol. Everybody look up. It looks like a sideways 6, doesn't it? This is a Greek symbol for sigma. Sigma is usually the sum or a total of something. So make sure you make note of that. This is our symbol for standard deviation. Step 3, graph the data on dot plots. We're going to do that today. And of course, we're going to summarize, which means analyze and compare data. Okay? So, yeah. Refresh. All right, so your attention, please. Copy this next example. If it fits, those of you that have small font, you can fit it under the steps. Copy this one, example 1A. And those of you that don't, copy this one in the back of your notes. Example 1A, it says find the mean, median, mode, and range, and standard deviation. And they give us 3, 5, 4, 2, 1, 2, 4, and the table. So copy everything up to the table and the standard deviation symbol, and then we're going to do this one together. Okay? Copy that. I'll give you 1 minute. Go. Let me move this out of the way. Put this up here somewhere, right there. Okay. Is everybody done copying this? Raise your hand if you need more time. Okay, I'll give you a little bit more time. Let me pause this. Okay, here we go. So, in order for us not to do double the work and so on and so forth, I remember when we first started with data, the first thing that we said, we need to organize this from least to greatest. So instead of writing it over here, we're going to write it in this column from least to greatest. So what is my first number? 1. So we're going to write 1. From there it's 2, 2. From there it's 3. And then from there it's 4, 4, and 5. Okay? So we got all these in order. Alright? So from there, we can actually answer some of the easy ones. So, what is our mode? 2 and 4, because it repeats. 2 repeats twice, 4 repeats twice. So our mode is 2 and 4, and I'm going to write it here underneath that word, so like that I don't have to take too much space. And from there, also by looking at the data, what is our median? What is our median? What's the number in the middle of this data? 3. That is correct. So write that on underneath there. Median is 3. And tell your neighbor how to find the range, please. Subtract the greatest from the smallest data, so that 5 minus 1 is 4. So we're done with the easy ones. So now we're going to focus on the mean, and then from there we're going to find our standard deviation. So to find the mean of this data, what do we do, everyone? Add all of them and divide by the many number that we have, right? So let's see, 1 plus 2, that's 3, 5, 8, plus 4, that's 12, plus 4 is 16, plus 5, that's 21. And then how many numbers did they give us? 7, so 7 fits in there 3 times. Now look, this is what I'm going to do. Look up, please. Let's write it right underneath, but let's use the symbol for the mean. Do this, x with a little bar on top, and you're going to write equal to 3. That's the symbol for mean. Now, why did I write it like that? Because I want you guys to understand the symbols that they give us over here. What does this next column say? It says deviation from mean means all numbers x. What are all my numbers x? 1, 2, 2, 3, 4, 4, 5, all these. And we're going to subtract the what? The mean, which is what? 3. So I'm going to rewrite all these numbers. 1, 2, 2, 3, 4, 4, and 5. And I'm going to subtract the mean from each one of those. I'm going to take away the mean. Get it? They're going to become nice. 3, 3, 3, 3, 3, 3, 3. And that's going to give us, this is what? -2, -1. This repeats. This is 0. 1, 1, and 2. How we doing? Alright, so now that we found the deviation from the mean, look what it says on the next column. It says you're going to take that number, the difference of the deviation, and you're going to square each one of those. So what do I write here? -2 squared, -1 squared, -1 squared, 0 squared, 1 squared, 1 squared, 2 squared. Alright, so therefore this becomes -2 squared is what? 4. This is 1, 1, 0, 1, 1, 4. Let's see, this is a little bit off topic. Look up, please. If I read this number 41101114, that number is called something. Who knows what that number is called? When a number starts with a certain digit and all the numbers reflect and they end up the other way around. That has, yeah, they're symmetrical, but it's called, it has a particular name. Does anybody know? No? They're called palindromes. Palindromes. Yeah, so whenever, let's see, what was the date that we had for January? I don't remember what day we hit that it was a palindrome date. Anyways, are we there so far? All right, so at this point, check this out. Look up, please. Here go the steps. We wrote this in order from least to greatest. We found the mean. Then we found the deviation from the mean, which means we took all the x values, subtracted the mean, it gave us this difference. From there we squared that, it gave us this. Now we're going to find this. Look up. What are we going to find? Okay, we're going to find the standard deviation, but first we need to find what? What is this called? The mean. So find me the mean of these numbers right here. 4110114. Let people do the computation, please, and you have your calculators, so do that. What'd you get for the mean for this one? Isaac. Okay. Hands if you agree to 1.71. Okay. 1.71. Okay, that's the mean. But to find our standard deviation, everyone, what would be our last step? Take the square root of that, and that's going to give us our standard deviation. So on your calculators, make sure you press the button that starts with square root of x, and that's going to open, it's going to say on your screen, square root, parentheses, so like that you can enter the rest. Be nice. Once again, you're going to clear your screen, you're going to press square root of x, which is going to give you this on the screen, square root parentheses. Type in the number, close the parentheses, and equal. Who's got it? Okay, Kendra, what'd you get?
1.307669.
So if we round to the second digit, that's what? 1.31. Hands if you got that. That is correct. That's our standard deviation. So, any questions with mean, median, and mode, range, and standard deviation? You think you got it? Be nice. So, what I'm going to do, I'm going to push this next example to your screen, so like that you don't have to copy the entire problem, but I want you to answer every box on the screen. Here it goes. Okay, here it is. Example 1B, it says find the mean, median, mode, range, and standard deviation of 10, 15, 10, 20, 10, and 25. Okay, I'll give you guys, show me with your fingers how many minutes you want. I see some 2, some 1s, 2s, no, just kidding. 5 minutes, go. I'll give you 5 minutes, go. Okay. The correct answers. Median is 12.5. Mode is 10. Range is 15. The mean was 15. And the standard deviation is 5.77. Hands if you got that. Okay, I know the screen does a lot of funny stuff. So let's just clap so that it can go away. Get it? Because it's funny. Never mind. All right, here we go. So how comfortable are you with these? Pick one being the lowest, 5 being the highest, with measure central tendency and standard deviation. You can choose more, but just give me one, please. Let me forward this. Okay. So, let's see. See where we're at. Some 4s, some 5s, some 3s, 4, 5, 3s, 4, 5, 3s. So, according to our graph, let's see, we got about 60, 70% in 4s and 5s. Almost 90% from 3 and up. All right, so we're not bad. So we're moving on. Let's move on to the next one. So the last example that we're covering is this one. It says, an ice cream truck offers items at 5 different prices. Mr. Q counted how many items were offered at each price one day. Make a dot plot of the data. So check this out. So if I was to give you a table like this, first of all, we need to set up our number line, right? Because we only need one number line for the dot plot. And you need to scale it accordingly. Look up, what is the first price that it starts with? $1. And it goes up and increases by what? 50, and 50, and 50, and 50. What I'm going to do, I'm going to go one below this, and if it's increasing by 50, what would be my first number here? 50, or 0.50. So that would go 0.50, which is right here, which means these are going to be 25 cents each. So this would be 75. So my next number up would be 125. The next number up would be what? 1.5 is 175. So this one is what? 225. So this one is 250. 275. This one is 3. This one is 325, so this is 350, and I'm going to stop at 4. Focus, please. So, dot plots. They show the frequency of whatever data they give us. So according to this, I was checking out a truck, an ice cream truck, and the items that they sold. So, what is the, how many items of the $1 did they sell? 5. So we just do the frequency. 1, 2, 3, 4, 5. How many items of the 150? 3. 1, 2, 3. How many items of the 2? 6. 1, 2, 3, 4, 5, 6. How many items of the 250? 4 of them. 1, 2, 3, 4. How many items of the 3? 2. So according to that data, okay, let me stop right there. What would you conclude?
People want to get the better ice cream, so they get right now. People want to save money so they get the cheaper ice cream.
Okay. Who can give us a generalized comment according to the data? What do you guys notice? Here are the number of items. Yes?
People get the ice cream that's $2. The most people, I don't know what it's like.
Most people get $2 items. Does that make sense? Now, if you were the owner of this ice cream truck, what would you do with that data? Think about it. Talk it over with your neighbor. What would you do with this data? Okay. Volunteers. Who can volunteer? Let's see. Yeah. Yeah.
Okay. We would make, or if I was an ice cream
Owner.
person, I would make most of my items cost like $2 or around that.
So make items cost around $2. Okay. What else? Yeah.
I make the stuff that's cheap cost $2.
Okay. So kind of like around the same area. Okay. I heard over here. What did you say, David? You forgot. Yeah.
Raise the price.
Raise the price of the $2 item.
How would make it cheaper so people buy more?
How about buying more items of the $2 to sell more? Does that make sense?
Everything like $2.
Yeah, or make everything $2. So that's how these dot plots are used. They're to look at data in a simple way and make decisions on a day-to-day basis. Does that make sense? So with that said, I want you to do this next one by yourself. I'm going to push it to your screen. There it is. Go ahead, fill that in, please, on your screen, and send that back to me, please. I'll give you guys 2 minutes. Go. All right. Show me with the fingers how comfortable you are with dot plots, 1 being the lowest, 5 being the highest. We've got some 4s, some 5s, 4 or 5s, 4 or 5s. Some of you need a manicure. All right, here we go. Our home plate for tonight, there's a play sheet in the back by the coffee machine. Play sheet 13.2. Make sure you do those tonight. Have a good one, everyone. Enjoy your home plate. See you guys tomorrow.